Today our topic is acids, bases and salts. We will divide this chapter into 4 parts: acids, bases, indicators and salts, and we will study one part at a time. Today we will begin with acids. Now the word acid came from the Latin word acidus, meaning sour. The characteristics of acids, if we see, all acids are sour in taste, they are soluble in water and they are corrosive in nature. Now let's go into the definition of acids. How do we define acids? An acid is a compound which, when dissolved in water, produces hydronium ion as the only positively charged ion. So if you dissolve any acid in water, it will ionize and it will result in the formation of an hydronium ion. And this hydronium ion will be the only positively charged ion. No other positively charged ions will be produced. Some of the examples of acids are hydrochloric acid, sulfuric acid, nitric acid, citric acid, acetic acid, and so on and so forth. So let's see how dissociation of acids takes place in aqueous solution. Here we have a hydrogen chloride molecule. This hydrogen chloride molecule contains a chlorine atom and a hydrogen atom. We have dissolved this hydrogen chloride molecule in water. Now, when hydrogen chloride molecule is dissolved in water, what happens? The hydrogen atom of hydrogen chloride molecule forms a bond with the oxygen atom of the water molecule, resulting in the formation of a hydronium ion. Along with it, a chloride ion is also formed. So, hydrochloric acid on dissolution in water gives rise to hydronium ion and chloride ion. And you can see there is no other positively charged ions other than hydronium ion. We will see some more examples now. Now let's take the example of nitric acid. We have dissolved nitric acid in water. So a molecule of nitric acid ionizes into hydrogen ion and nitrate ion. This hydrogen ion is actually a proton. It's highly charged. So what happens? It cannot exist independently. It combines with a water molecule, forming a hydronium ion. Now, if we write the overall reaction, how does it turn out to be? A nitric acid molecule reacting with a water molecule gives rise to hydronium ion and nitrate ion. As you can see here again, hydronium ion is the only positively charged ion formed. So we have one more example. Sulfuric acid. Sulfuric acid ionizes into hydrogen ions and sulfate ion. One molecule of sulfuric acid produces 2 hydrogen ions. Again, hydrogen ions cannot exist independently in an aqueous solution. So the hydrogen ion combines with water molecule, giving rise to hydronium ion, and sulfate ion remains in solution. So the overall reaction is sulfuric acid reacts with water molecule, forming hydronium ion and sulfate ion. As sulfuric acid generates 2 hydrogen ions, so you will get 2 hydronium ions when one molecule of sulfuric acid dissociates in aqueous solution. Now we will move into the classification of acids. What are the different ways in which we can classify acids? So the first classification is based on the source of acids. Where do we get the acids from? So on the basis of source of acids, acids are classified as organic acids, inorganic or mineral acids. So what are inorganic acids? Acids derived from plants are called organic acids. So they contain a carbon atom along with a hydrogen atom. So in organic acids, carbon atom is one of the central atoms. And you also find an oxygen atom present in organic acids. Example of organic acids are acetic acid, citric acid, oxalic acid. Inorganic acids or mineral acids. Now, those acids which has been derived from minerals are called inorganic acids. or mineral acids. Example, hydrochloric acid, nitric acid, sulfuric acid. So these inorganic acids usually contain a non-metallic element, hydrogen, and oxygen. Oxygen may or may not be present. Like in hydrochloric acid, you don't have oxygen, but in nitric acid, you have oxygen. Now we will classify on the basis of molecular composition. The two types of acids are hydracids and oxyacids. Acids which contain hydrogen and a non-metallic element other than oxygen are called hydracids. Oxyacids. Acids which contain hydrogen, a non-metallic element, and oxygen are called oxyacids. So if you can see, hydracids, oxygen is absent, and in oxyacids, oxygen is present. Now, on the basis of strength of acids. So what does the word strength of acid means? The strength of acid means how strong or how powerful that acid is. And on what the factor does it depend? It depends on the concentration of hydronium ions present in the aqueous solution. So if you have an aqueous solution of an acid, the number of hydronium ions present per liter of the solution will determine the strength of the solution. So we can also see the strength of the solution will depend upon how many molecules dissociate or ionize when the acid is dissolved in water. So if you have a molecule of acid and it dissociates in water, it produces hydrogen ions. So on the basis of strength of acids, we can classify the acids as strong acid and weak acid. A strong acid is one which undergoes complete dissociation in aqueous solution to produce a high concentration of hydrogen ion. Okay, so a strong acid undergoes complete dissociation and it produces a high concentration of hydrogen ion, whereas a weak acid undergoes partial dissociation in aqueous solution and produces a low concentration of hydrogen ion. Now, please note, the word complete dissociation and partial dissociation are the key words here. These words have to be present for you to get marks during your exams. So I will just elaborate a little more on this point. If you have an acid, say 100 molecules of a particular acid, out of that 100 molecules, if majority of the molecules ionize and produce hydrogen ions, you will get a strong acid. And if out of the 100 molecules, very few, maybe even 10% molecules just ionizes and the rest of the molecule does not ionize, then you will get a weak acid. We should note here, a strong acid usually contains ions and a weak acid contains both ions and molecules. One more point of importance here, all organic acids are weak acids, but a mineral acid can be both strong or weak. On the basis of concentration of acids. Now, concentration of acid means the amount of acid present in a definite amount of its aqueous solution. So it's usually defined as the number of moles of acid present in per liter of the solution. Now, concentration of acid thus tells us about what? About the amount of water present in the acid and not about the strength of the acid. This is a very important point we had to note. It will tell you about the amount of water present in the acid. So it is not telling you about the amount of hydrogen ions, or what we are saying is it's amount of the water and the amount of acid. That relative amount of acid and water determines the concentration of the acid. So dilute nitric acid can be stronger than concentrated acetic acid. A concentrated acid has a relatively high percentage of acid in its aqueous solution or we can say it contains very small amount of water or no water at all. A dilute acid has a relatively low percentage of acid in its aqueous solution, or it contains a large amount of water. Precautions to be used while handling acids in the laboratory. You should never try to taste or touch acids which are used in the laboratory. Acids are very harmful, very corrosive, so you should never taste or acids. We never add water to concentrated acid. So if you want to dilute a concentrated acid, you have to add acid to water and not water to acid. Why? Water is not added to acid as this reaction is an exothermic reaction. A lot of heat is generated when an acid comes in contact with water. This heat generated may cause the acid to splash out and fall on the person who is working with the acid and cause severe burns. The glass containers may also break and it can be fatal to the person. Now we will go into the next topic, basicity of an acid. This is a very important topic. So what does basicity of an acid mean? The number of hydronium ions produced by one molecule of an acid in its aqueous solution is called the basicity of the acid. Now let's take this example. Here we have nitric acid. We have one molecule of nitric acid. This one molecule of nitric acid in its aqueous solution dissociates to give us one hydrogen ion. So its basicity is 1. If you take the example of sulfuric acid, one molecule of sulfuric acid will dissociate to give us 2 hydrogen ions. So its basicity is 2. So we can classify acids on the basis of basicity as monobasic acid, dibasic acid, tribasic acid. A monobasic acid produces one hydrogen ion in aqueous solution. So its basicity is 1. Examples are hydrochloric acid, nitric acid, even acetic acid is an example. Dibasic acids, what happens? One molecule of a dibasic acid produces 2 hydrogen ions in aqueous solution. So its basicity is 2. Sulfuric acid and carbonic acid are examples. Tribasic acid. One molecule of a tribasic acid will produce 3 hydrogen ions or hydronium ions in its aqueous solution. Example, phosphoric acid and citric acid. Okay? So we will stop here with the classification of acids on the basis of its basicity.